and if you're understanding all that, you're great. I want to show you something. I need like a blank space. I'm gonna cover up all of this, and bear with me for a second. All right, I need like a drawing board here. That's what we've got. Okay. Just so you can see how things start to connect. If you understand everything we did, you're set. But I want to show you this real quickly, how this formula connects to the Pythagorean theorem formula. Pythagorean theorem is this: a squared plus b squared equals c squared. Now let's say I solved this for c, and we practiced a little bit solving for a variable. I can't cancel out all the square roots, but I can take this, or all the squares, but I can take the square root of both sides. And when I do that, this cancels, but these don't go away because of that plus sign. So really all we're left with is c is equal to square root of a squared plus b squared. That's another way of looking at it, okay? It's another way of solving Pythagorean theorem. If you are just looking to solve for c, you can plug in a and b and you're done. All I did was a little equation manipulation. Again, this is just side note. You don't have to know this, but if you want to see how it connects, that's what this is. Now, if we look at our distance formula seems to have a similar setup. It has the square root, big square root, of a quantity, this here, squared, such as a, so this is like our a, plus a quantity, like we have here, set of parentheses, that's like our b squared. So this is a very similar. Now, where did they get x2 minus x1? Well, a squared, if we have a triangle, would be like this distance. B squared would be this distance up and down. Well, the distance across, if we were to make this a triangle, the distance across from here to here is x2 minus x1. This is x2, this is x1. The distance is x2 minus x1. That's how they get the first a value, the a side of our triangle. Then we take a look at the y's to find our b value. That's going to be, this point here, the y value here is y2. This point here, if I carry it across, the y value is y1. The distance between here is y2 minus y1. So that's my b value. Now if I take the square root of the whole thing, little squiggly, that ends up giving us the distance formula, which matches. This is really our a squared, that's our b squared. It's the exact same thing as a Pythagorean theorem, it's just using different notation, applying it to this specific concept. So it's kind of neat. Again, that was a side note. If it didn't quite click, there's a lot there. I'm not in any way